The next group of elements that we're going to take a look at are called the intertransition metals. And this group of elements actually forms this island that we typically see beneath most periodic tables. And even though it looks like it's a separate part of the periodic table, it really isn't. This entire section, sometimes 14, sometimes 15 columns wide, would actually best fit right in here in between columns 2 and 3 of the periodic table. And the reason that they are placed where they are is that if you can imagine that entire section in between columns 2 and 3, the periodic table would be twice as wide as it is now. It would be a lot harder to work with, a lot harder to print in textbooks or on wall posters, things like that. So basically that section was cut out and brought and placed underneath the main body of the periodic table. And then those first two columns were brought over. And so it's a much more compact way of representing the elements. You just have to be careful when you get down towards the bottom of the table that you follow the atomic numbers in order to make sure that you divert down through that section. When we look at these two series of elements, okay, a series is another name for a row or a horizontal arrangement of elements. And so the top row, starting with lanthanum, is known as the lanthanide series. And sometimes it also goes by the name of rare earth metals, although that name isn't quite accurate because the rare earth metals really aren't rare. It's just that they are so similar, chemically speaking, in the way that they react, it's very hard to purify them. It's very hard to separate them from one another. So the cost when it comes to dealing with lanthanide elements, rare earth metals, isn't the rarity, it's the processing that goes into purifying them. The elements that are in the lower series there are known as the actinide series elements. And those elements, their claim to fame is that they are all radioactive. They all are unstable and they will radioactively decay. Uranium is the heaviest naturally occurring element that we have on the periodic table. Everything beyond uranium, element 92, from neptunium on up, they are all synthetic elements. And if they're synthetic, that means that they are not naturally occurring on the Earth, and the only way that they will be generated is in a laboratory. Particle accelerators, basically taking two smaller nuclei and accelerating them at high speeds and ramming them into each other to see if you can make one big larger nucleus. And as you can imagine, those larger nuclei themselves aren't going to be real stable, so they will begin to decay away. So the elements that I'd like you to know, out of the rare earth metals, the main ones would be the first one, lanthanum, after which the series is named lanthanide series, and then neodymium, Nd. We hear that a lot when we talk about magnets, like the very strong, powerful magnets. They're still iron magnets, they just have a little bit of neodymium that's mixed in with the iron, and some other elements usually as well. Most of the elements from this section that I'm asking you to learn come from the actinide series, particularly the first half, really. And so you've got actinium Ac, thorium Th, protactinium, it's kind of a fun one to say, Pa, and then the familiar uranium with just U. And then, again, starting the synthetic elements, neptunium Np, plutonium Pu, americium Am. Notice the C has an S sound to it rather than a hard K sound. It's not Americum, it's americium. And then finally, curium, Cm, named after Madame Curie. If we continue onward then, the next section, so we're back up in the main body of the periodic table, and we're getting closer to the right-hand side. And on many periodic tables, you may see a stair-step line, either as a very bold-faced, very distinguishable feature. Sometimes it's a little more subtle, it's just a thin line. Some periodic tables don't show the stair-step at all. But what that is a line of demarcation, of separation between the metallic elements, which are on the left and center part of the table, and the non-metallic elements, which are on the right-hand side of the table. So if you're thinking of it like a map analogy, it's kind of like it's the Mississippi River. Even though that's not right smack dab in the middle of the United States, it's generally thought of separating the East from the West. Okay, so the section that we are looking at are these metals that are just underneath that stair-step line, this little corner pocket here. You can see the one name that they are referred to as is the other metals, very ominous and nondescript. Sometimes you'll also hear them referred to as the post-transition metals. Again, post meaning after, so after the transition metals. And many of these are very common and have common uses, and we are familiar with them, or we can think of where we've experienced them. Starting with aluminum, Al. Right, very malleable, very soft. Generally, these other metals or post-transition metals are softer than the transition metals. They have lower melting points than the other metals that are in the transition metal section. So aluminum, Al. Gallium, Ga. That's an interesting element. It has a melting point that is just above human body temperature. So if you hold it in your hand, or just above room temperature, I should say, if you hold it in your hand, it will actually melt. Indium, In. Tin, right, with its symbol Sn, there's another one that has a unique symbol. Doesn't come from the English name, but rather the Latin name. And when you consider the Latin name for tin is stannum, then it's easy to see where the Sn comes from. Then you have thallium, Tl. Lead, with its symbol Pb. No, it doesn't come from peanut butter. Pb comes from the Latin name plumbum. And we see some other words in our English language that derive from the same Latin word, like plumber and plumbing. And if you wonder, well, what's the connection there? Think about, what did water pipes used to be made out of? They used to be made out of lead. Now, over time, chemically, if they begin to degrade, then you start to get lead leaching into the water. And if people are consuming that, then they're going to end up with lead poisoning. There's also in construction, okay, when you plumb a wall, P-L-U-M-B, it means you're making sure that the wall is standing straight, the frame of the wall is standing straight. The tool that carpenters and contractors will use to do that oftentimes is a plumb bob, which is just a heavy metal weight, usually lead, at the bottom of a string. And you hang that string, and the heaviness of the weight keeps that string perfectly vertical. So as you bring the frame upright, you can make sure that you have that wall positioned in a straightforward manner. All right, and the last one is bismuth, Bi. Forms some really interesting looking crystals, very iridescent in nature. And so 7 elements in the other metals section combined with the 10 elements in the inner transition metal section make up the elements that you are being asked to know for your next assessment. Thanks for watching. Have a good day.